Okay. Okay, so this is where we ended last evening, right?
Oh. Can you turn off the network there for me? If you're not using it.
Can you hear me?
Yes, we can hear you.
Okay. So the past 2 days, we've been working on this. So we did some modeling yesterday. No, and on the day before yesterday, on Monday. Sunday. Then we continued yesterday, and now today we continue. So what we've been able to do was do the columns and the beams and the slabs, just modeling. And then we ran an analysis. I think that's why we ended yesterday, last night. So it's time now to actually get to design. So we ran an analysis here, and it's showing that it's the analysis passed. So we go to the design icon now. So on the design icon, we can start with the columns. Okay. So if you remember from the class that we had, most of these members have failed because it starts to design. It starts to apply the minimum reinforcement unless you do the interactive design button. So from the first class that we had, part of the reason why I had to model the column from the 8th floor and then have it run all the way down is so that we could have less columns in our building. If we had gone the generate column way, where we model on the 8th floor and then we generate, the way we have these columns, I think these could be like close to 100 columns. We're going to have this same number, let's assume it's 100 times 8, or times 7 rather. So we're going to have like 700 columns that we have to edit and we have to present on a paper. But the way we have these ones running from top to bottom, we will just work on one. We work on it for the entire structure. So note that the other generating option was wrong. It's also okay, but just to reduce your workload, you can use this method. Okay, so we'll start to the design status here says that it's failed. So we open it and see why. Yes, Mr. Mshota.
Oh, so before you just begin this design process, I had a question from yesterday's video.
Yes.
During yesterday's
Yes.
video, I saw you were adding the rebar before the analysis. Is that what you did?
Yes, that's what I did.
So why did you take that approach and not just run an analysis and let Prota give you the steel, and then now you can decide whether you keep that one or generate or set up your own?
Okay. So when I was adding the steel, it wasn't really that I was adding the steel. It was how the steel should be sitting. If I can go back to, yeah, like you said before we go, I went to the settings tab, okay? And then I said, okay, in the column, design, I think it started from column containment. I was basically commanding how the rebar should sit. In an event that I had these options and clicked as it was, I was only going to confine my design to having one ring around and then having those tie links or ties, column ties. But because I clicked everything here, I'm exposing now the column design to be able to use all these 4 options of stirrup placement. So that's just an example. So it's the same thing I did even on the wall containment. Instead of this point where it's just using one link around and then ties, I clicked this one which has got end zones. So it's not really that I was restricting it. I was just giving it a preference, what I prefer the reinforcement to be laid out like. I hope I'm. So when it comes to column bar size, I was just choosing the bars that I want to work with. So I said I want to work with anything from Y12 to 32. I could have clicked 10, but I don't want to see 10 in my column. Okay, so even 12, I would say okay, it's just because I just put it there, but ideally for a high-rise structure like this one, I would just command to say I just want to have anything between 20 and 32. And when I say okay, it will modify itself to these parameters that I've placed in here. I hope I've answered your question.
Yes, I understand. Okay, but just one last question. Is this, have you used the 2018 before or 2019?
No, I think the first one I used was 2021.
Oh. Okay, because in this late this is an earlier version that you're using. In the older versions, there's something that you do. You go to edit materials, and then this process. So I wanted to know if it's similar to that process.
Oh yes, it's similar. It's similar. It's actually, I did that actually. I
Oh.
did that. I came on the analysis before I analyzed, remember?
Mm.
Okay, before I analyzed, when I came here, I did this, which was where I'm coming from, okay? After this, I came to the loading generator. I assigned the load cases, okay? Then I came to the wind load. I assigned load cases on the wind loading,
Okay.
okay? Then I came to edit materials. Then I said, when I just clicked this, just one, I said, okay, I would like to use C40 in this design. So I just clicked one. I didn't go to them icon by icon. So I used this option here where it says apply to all members of this material class in this story. So when I click this, everything that I've set in here happens to all the members, that is columns, shear walls, beams, slabs, composite slabs, ribbed slabs, and to the links. So that setting happens to all of them. Similarly on the steel, okay? If say for instance, already here you can see that it's 460, yeah? So if I say I want to adjust it to 500, grade 500 steel, type 2. So I'll say I want to adjust to 500, okay? Then I'll say, instead of this just changing for this particular one, I'll click this one so that the same setting can apply to all the member classes in this story. So when I click OK, everything here will be adjusted to grade 500. But I said, I don't want to use grade 500 in design. I want to design using grade 460. But when we get to specify what grade of steel they use, we specify a grade higher. Okay, I think that's why we came there. Similarly, I could even say, okay, I know I want to use C40, but let me design using C30. Okay, let me design using C30 so that when they use C40, I'm a grade higher. So that in an event that they use concrete, which gives us a strength maybe at 28 days, it gives us a strength of 28 or maybe 32. It still suffices. You understand what I mean?
Yeah.
So when I click that and say, okay, so everything here will be adjusted to that. So I maintained this because I'm not using steel here, like that is structural steel. So I didn't play with these. Then I went to the foundation. I actually didn't come here, but I have to do the same here. So even here, I say, okay, I'm using C30, apply to all members. Okay. Then I come to the steel also, I reduce it to grade that, apply to all. Okay. So, but when we get to specify, on the title block where we specify what materials we actually specify 500 grade of steel and then C40 concrete.
Okay, I understand.
Okay, great.
But it will be better
So
if I can just go and review the other video.
okay, yeah. Okay. So if I start analyzing again, it will take, maybe it may take lesser time. So remember that we had some errors. Huh? Can we start by sorting out the errors, or we proceed, then we sort out the error? Okay, let's sort out the errors that we had in the building analysis. So we had about 16 errors. Okay, so now if you look at these errors, it's best to actually write them down. So the number of errors are 16. Huh? So these are just modeling errors. They don't affect analysis. So the first one there, we say on story number 8. Number 8, we have a situation where the slab 8S3 is overlapping with the beam 8B157. Then on the same story, we have the slab 8S3 overlapping with the beam 8B158. So I'll just go and sort out these two. Then these ones, it's the same thing. So I don't want us to waste so much time sorting out these errors. But once I show how I sort out these two, then we come back to check the building model. You'll be able to see that what's happening is just that we have modeled the slab and it's crossing the space where the beam is running. So that is recognized as an overlapping. So there's a way to sort out that, which we're going to do just now. So here I say close, and then I come back to story number 8. So easier way of finding the beam, it's better to actually find the beam, then you see the localization of that error. So we open the beams tab, then we look for 8157. 8157, 157 is actually here. So once I click this, I should see it somewhere. Okay, so it's here. So you've seen what's happening here. So what it's saying is that this slab is overlapping with this. So what I'll do is I can delete this slab. I know it will affect the building analysis. I say yes. So after I've deleted that slab, I'll just come back and say, I look for the same properties. So I use these ones. Okay, these properties. So I'll model again using beam region. So I'll place one here, and then I'll place another one here. Then I'll place a slab here. So initially, if I can zoom in, the slab was running all across this area. So it was overlapping with these beams in the same space. So now I've isolated this slab. This slab is only sitting on these beams. This slab is sitting on these beams. So when I go back to run the analysis, I shouldn't have this error. So there is the other, remember it was two beams that were showing overlapping. So it was beam 157 and beam 158. So now when I go back to analysis, I save. Oh my goodness, I didn't start recording. Apologies. Okay, I've started recording. So when I go back to, I've saved, so I go back to analysis, building analysis. I want to run the building model check. So I shouldn't see 8S3. So I had how many? 16 errors. Huh? I should see only 14 errors. So let's see if we're going to see only 14 errors. Yeah, so we have 14 errors now. So we've cleared 2. So number of errors is now 14. So similarly, if we go to story number 8 again, we should sort out this overlapping again. So we had 16, huh? Now we have 14. So it's either we can sort, if we start sorting all of them one by one, we may take a bit more time. So I would suggest that we proceed unless you say otherwise.
I think we may proceed.
We proceed? Okay. So to proceed,
Yes, we can.
we run the analysis. So I may actually even say reselect the bars so that it selects the bars with reference to the parameters that I selected. I don't mind about this because we're not doing any steel design, neither are we doing any composite design. So we run the analysis. Any questions so far?
No questions at the moment.
Okay. So we're dealing with the beams now. There's too many beams in this structure. Now imagine if we also had too many columns. So power has cut, but the only concern is on the internet. I hope the internet doesn't trip. We have a backup here. So if at any point my internet gets disrupted, you can, I think you can call me shorter so that I can use an alternative internet.
Guys, you've got internet, you've got alternative power, even have alternative internet.
No, like I'm using a router now. So now MTN in this region, when there's no power, the MTN tower that services us relies on Zesco. So if there's no power, the
maybe our friends
reception.
have got
Not yet. Not yet. Starting, not yet. Not yet starting.
Guys, Niza Po Mundia Obi. Which link did you use to join this chat? It was the same one I shared in the group, right?
Yes.
Saying is unable to join. I don't know why.
I use the same link in the WhatsApp. Is it which one? This one.
Then they say I'm unable to.
This is when it's 3 on story 4.
As we wait for it, show us some tips and tricks in AutoCAD and Prota.
Yeah, but I'm avoiding because you've seen all these I can't use them when it's running the analysis.
Oh, I hear you.
Yeah, I can't use all these. It has to finish the analysis. Maybe what I could do is no. Anyway, we're not. Let's not confuse this lecture. The returning was.
Yeah.
So one of the challenges that I found with Prota is that it asks for a little more effort when it comes to detailing. So I don't know how you finish the drawings, Shota, but when it comes to beams, I use the beams just as they are. They are detailed quite okay. Then when it comes to columns, I have to change I use the steel as it comes, but I have to remove the stirrups. You know what it does to the stirrups, huh? There's some draw of yours. If you have like 40 stirrups in a column, it will draw them as lines. So we cannot detail them like that. Columns have to be detailed differently. So it asks for extra work in detailing columns, and it also doesn't show the foundation. So you have to manually detail that one. Then you've seen what it does with the foundations. It doesn't accurately show you the position of a starter bars or the starter column on the foundation. So you have to add in some extra effort there. The slabs, the detailing is not the one in the code, so you have to add the extra. So I think essentially the only thing that we use the most is the beams as they are and the layouts as they are. But for the slabs, beams, so the slabs, columns, and foundations, you have to add in some extra detailing.
For me, it shows.
It shows what?
The foundation where the anchorage between the starter bars and the footing.
What? Do you know what I mean? Like it. Do I have a?
Okay, let me show you. Let me share
Do
my.
I have?
Let me see if you guys will be able to see my screen.
Okay.
And this is according to what we did previous.
Well, even the shape shows you the column and the pad base.
Hey, you advise anyway. You advise if I don't know if you guys can see.
Okay, let me see. Unless you export it from Prota Steel. Prota Steel, yes, it does.
You mean structural steel or reinforcement steel?
No, reinforced concrete. So you can get the form from Prota Steel, then bring it back to.
Can you see my screen?
Yeah.
Yes. I can
Okay,
see your screen.
so this is previously from that model that we did. I've got two. Oh, this is
Okay.
the one.
So let me see your column. Let me see your column elevation.
Okay, so my column elevations are here. So here it shows that from my natural ground
Exactly.
to here to minus 1.3, it shows, and then from 1.3, if I use foundation bases of 400 millimeter thickness, here it will show. Yeah, and that.
Exactly. So you've seen my point, huh?
Now let me show you. Here,
Uh-huh.
there are these the three, and then there's this one alone.
Mm-hmm.
It shows because the distance is 19 here from there to there, but however this one is
Yeah.
1950. This is 13. This is 1950, and it shows you that it anchors 200. Meaning, if you place it there at the base, the bottom, it scatters that 400. If you add 13 plus 400, it gives you 19 plus this anchorage there. Or it actually gives you 7, right?
So now those are calculations. So if you're going to present a drawing, you don't want to. Okay, analysis is done.
Okay. Let me stop sharing the
And
screen. But you understand what I mean, right?
yes, I get what you mean. So there's also some extra effort.
Yeah.
Okay. So analysis is done, and we have satisfied story drifts in both directions. Okay. So in
I
an
don't see
event
your
that
screen,
there
man.
was one of these, I'm not sharing my screen.
Mm, Try to reshare because I was sharing mine. Oh.
Can
Try
you see
to
my screen?
Yeah, try to reshare because I was sharing mine, so maybe it overrode yours. Yeah, now we can
Can you see
see.
my screen?
Now we can see.
Okay. So I'm saying uh, in direction number 1 and direction number 2,
Hello?
it says the relative story drift satisfies the limits.
Alright,
So
let me
there's
call you back after a
rigidity
while.
in both, let me use this, rigidity in both directions, in direction 1 and direction 2. So in an event that one of these was not rigid enough, what we were going to have to do is going to look for ways of making it stiff in that direction. So, but the way we did our shear was, it suffices. It means like we have sorted out our. In some cases, you don't even do your shear hose, but the columns are able to carry lateral loading. In some cases, okay. So you will have satisfiable
Do
story
you remember
drifts
the
in either
distance for
direction.
these
So okay.
the shovels?
So the analysis has is okay. Then when we go to post analysis, you're able to see like the analytical model, which I can open. We open the analytical model. So from the analytical model, there are particular things that you are able to look out for, like you're able to see the activity of shear, you're able to see the activity of axial loading, and moments, both hogging and sagging moments. So if I'm to I just want to, okay, so it's lagging a bit. There's something I want to do. I want to remove the tile so that I'm just able to look at one view and take go. So they said, okay. So this is the analytical model for our structure. Okay. So at this point, it's just showing nodes. So if I'm looking at it in this direction, for instance, I'm able to just say, okay, I just want to see the diagrams. And in this case, I want to see the sagging moments. It's a bit slow. Ha! It's dragging. It's so slow. Okay. So hogging moments, sagging moments. So we're able to see, like, for instance, in this case, like our maximum moment in this case is 33.4. We won't see anything larger. This is 33.3, they are less. So you can actually have a look at them. So you're able to just see what's like your maximum. I think this is now our maximum, 35.5. So in an event that you're going to do any external work outside this program, you're able to just use these figures. You're able to use these figures. There are times that I'm doing connections, like steel connections, maybe in a different software. Usually maybe Tech. I'm using Tech. That's advanced steel design. So I want to come and see such things. Like I want to see what moments are active here in this zone. I have, like, this is the end of the concrete, then I have a steel maybe connection coming this way. So I want to see what moments are at work here, what shear forces are at work in this zone, so that when I'm doing some work outside, I'm able to. So you can get all that information from here after you're done modeling. Anyway, for now, we're doing everything within this, so it will automatically work itself. Okay, so we can close that. I think even you can even do an animation here where you get to see the behavior of the structure, so that you actually, you can also see the behavior of the structure per load. So you can see this is some deflection that the structure is having here. It's exaggerated. You can see it dancing, but the maximum deflection is 0.012. 0.012. This is like 12 millimeter, is it? Times 1000 is like 12 millimeter. 12 millimeter deflection. No, this is actually millimeters, 0.012 millimeters. So very, very minimal deflection that we have here. Negligible, actually. So we can close that, then proceed to design. So in the design now, this thing is so slow. Save the work. Okay, so in the design now, we start to design, we start to work on columns. Let me go back to the tile. We start to work on the columns, huh? Columns.
I'm pretty sure it was.
So we start with the first one. Open. So we can see our utilization ratio. Part of the things that we need to look out for is like this, the utilization ratio here. So the utilization ratio should not be more than 1 for the structure. It should not be more than 0.99 for the structure to pass. So we can see it's 6 point something. So this is way high. So we can either do interactive design to design this column, or we just physically change preferences. Okay, interactive design, it will design on its own. So there's still issues here. even after interactive design. So it says steel ratio limit exceeded. So there's too much reinforcement in the column. Okay. So what we have now is a situation where the cross section of the column is too small. Then we have more reinforcement. So let's try to use Y32s in the corners. Manually, now I'm doing it manually. Yeah? Y32s in the corners. Then I reduce these to 3 bars. Then let me try to use 20. 25. So there's some reinforcement that you see that, okay, this is not making sense. I have to increase the cross section of the column. So this is too much reinforcement. So I may just have to go and increase the cross section of my column for it to make sense. So to me personally, it makes sense. You have this column active over 8 stories. It's 450 by 450. I think you need a bigger column than this. I think people that have been to the King's Hospital may agree with me. We actually had columns as large as was that 600 by 600. The ones that were in the I remember why, Mr.
Yeah,
that's
bottom
Yeah.
is 60 bars.
Sorry?
That's true. It's correct. I was just
Yeah.
whispering to
So-
myself here. Maybe 600 by 600 would do.
Yes. So 600 by 600 would do. So what we do is we'll just close this, and then it's easy to modify them at this point. So when you just notice that you're putting in too much reinforcement than is required, you change the cross section. It's the same even with the beams. There are times when you just need to adjust the width of your beam. Maybe it's not just correct. It's not just giving you sufficient section of the member. So we come to the columns. We can actually modify them from this.
The section.
Okay.
Oh.
So we go to the columns. So click the first one, scroll down, and click the last one.
So I want to go to the column
Then
table.
right click, right click, then edit section. So now what we're going to attempt to use is 600 by 600. Okay, then okay, yes. So we've changed all the columns here. I think except, remember when we were modeling, there are some columns here that we started from, others started from the 4th floor to the 6th floor, then others started from the 6th floor to the 8th floor. So what we may have to do is change them. Okay, I will show you how we can change them. This thing has just frozen a bit. I may have to restart this. For some reason, it's slower than it should be. Probably because my PC has been on from morning.
So correct. So behave, my friend.
There's even an icon for inserting a column jacket in Prota. So if you design the column and it's not like, okay, you sorry?
Is that retrofitting where you add a column jacket or something else?
Yes, where you add the jacket like around it. So you've seen what's happening here. We've changed these. I think these are now 600 by 600. So what we can do is now change even this. Remember these columns, huh?
Yes.
These ones. Who was that who talked about them that day?
It was Paul.
Yeah. So what we can do, I don't want to delete any of them
What are the
because we may
effects of
just bring
having bigger
issues to
columns on a higher level and smaller?
you get you have bigger columns on the top, and then they are supported on the smaller columns.
What is the effect?
It's there'll be some form of squashing, obviously, either squashing or buckling. They will fail.
How about the concept of floating columns? Have you ever used floating columns before?
Yeah. I've done some floating columns before, but you need to have serious beams.
For me
Oh,
personally,
I've come
just
here
having
now.
solid
Okay, even here,
foundations.
even you can actually even edit from here,
On the column
from
table.
the column table.
So this meeting is about to end the next 15 minutes. I don't know whether you create a link or I should create a link.
Why does yours end?
60 minutes free. It says with your team's plan you
Oh,
can
yours
speed up.
is yours is free.
What does that mean? Yours is not free. You pay for Microsoft Teams.
I pay Microsoft. You think they give free? Okay, so we can try to analyze this now. Save.
Yes,
So maybe as this is analyzing, if it ends, then I'll create another one.
okay, but just keep it running. The OBS, keep the OBS running. Recording.
Yeah, the recording is running. Did you upload the one for yesterday?
No, because my
Number 10.
number 10 is the thing is that if I upload from my end, the screen will be too small. Like I'll be recording.
But you know what happened?
Eh.
I recorded number 10, but I didn't stop it. So it recorded like for 4 more hours after the time we finished. So I only realized when I was going to bed, like around 2.
Oh, you
That
can
it was
edit.
still recording.
You can edit videos using ClipChap. ClipChap is like a good software. It's a Microsoft.
ClipChap. Okay.
You can cut out the excess.
Okay. I'll install. I'll have that one installed. Then I can edit.
Okay.
The beams is so the columns have. I'm sure you can see. If you actually went in, you'll see that some columns have passed already.
Because of the perfection.
Some columns are green, so that means the 600 by 600 nice for me. And then there's a principle for member designer. There's a principle that where we say that it's cheaper to actually use more concrete than to use steel in trying to achieve a satisfactory design. So you find that if even if you're dealing with a tensile member, like let me say, not a tensile member. Let me say if I'm dealing with a member in tension, like a beam, there are some times when I would try to achieve, say, for instance, I have a span of 8 meters, and I'm trying to make a beam that is 200 millimeters by 300 millimeters to to be able to support that span. It won't work. Even if I put a lot of reinforcement, it just won't work. So remember when you were doing column design in high school, like if you're doing member design, either a column or a beam. Sorry, not in high school, in university. So the first thing you would have to do is you design for the cross section first of all. So there were those checks like slenderness, deflection. Before you even think about putting in reinforcement, before you start calculating the area of reinforcement, you first have the cross section satisfactory. So that's one of the things that just happened just now. We had a situation where we had a column that is 450 by 450. The cross section has just refused. So even if we try to put in Y32s as reinforcement, it just won't work. So you go back to defaults, adjust your cross section to become something reasonable. Then you can use now your steel reinforcement to add in the tension that is required. Yeah. Sorry, man, didn't PC this road at all. Don't know why.
Oh my god. Everyone has gone quiet.
It's almost done. Okay, done. So the issue is on the beams. That's where our issue is. There are a lot of beams. Okay, so we go and try now. So we go back to design, columns. Some of them have actually passed. And the utilization ratio is making sense. But we have to drop it because remember, we haven't even loaded our beams. So once we load our beams, we're going to have, once we load our beams, we add loads to the slabs and so on and so forth. We're going to have some issues there. So for instance, this column, we may actually have to change this maybe to corner bars Y32. And then we have that. So 0.59 relatively a reasonable number. So to make things easy, we may actually have to copy this. I think let me change this, the shear design. Okay. So when you're changing the shear design, I wish I could draw. What can I use to draw? What can I use to draw?
Can you use AutoCAD or Paint?
Fish. Okay. Have you
You
ever
can use AutoCAD or Paint or the Paint software?
the Paint software? Okay. You can see the screen, huh?
You can see it. That's maximized.
So we have this. This is a column. So this is the column, huh? So if I'm going to have the shear force diagram, it will be something like this.
Yeah.
You know, huh?
This
So what this means is that as I am going towards the top support, I have maximum shear I'm going towards, my shear is increasing as I'm going towards the support on either side of the column. Okay? So what happens is that, look, you have either side of the support, sorry. So you have a support here, and you have a, so as I am, this is the column elevation now here. You have a beam running here. Pardon my drawing skills. Freehand. Okay. Then if this
Previous station has expired.
can you see my screen well?
Not yet, but give it some time. We go to the application in order for us to see the screen. Yeah, can you try to go to the Paint application so that we see whether or not screen sharing is activated? Oh, yeah, we can see the screen. Yeah.
Okay. So I was saying, if we take this as h, as the height of the column, then there's such a thing where you say h over 4.
So stop that state.
This region here, you want to have stirrups closely spaced, because in that zone you have quite high shear. So your stirrups, your links in a column take care of shear. So this is the other h over 4. Okay. So here you have closely spaced links. So in an event that your link size is maybe 200, you usually want to space half of that here. So if you specify the links at 200 spacing, then you do 200 in this zone. I'll use a different color. This one, this zone, h over 2. here you space them at 200, okay? Something like that. Then here you space them at 100 and here at 100. So the reason why I had to draw this is because of what I want to do here. So I'll minimize this, go back to Prota. You've seen here, you can easily just say, okay, 200 to go. And then you say where you have span, you use the h/2 value. So you leave it at 200. Then on the support, I usually drop it manually down to 100. So you can do 100 or you can do 150. For some reason, yeah, 100. Then I say, okay. So you can actually see it here. It says T10 200-100. So the first one, 200, is the span dimension of the stirrups. Then 100 is the support as you go towards the support. Okay, so at this point, we know that all the columns that are in this building are the same size. So I would like to just do a fast job and just say, okay, let me copy these bars, copy the bars here in this particular column. So I copy the bars, then everything that is showing an equal sign here, I click the first one, I scroll down to the last one. So there are some here that are not, like here, you've seen these are still 450 by 450. I don't know why I didn't edit this. I'll come back to them. So I click everything that is 600 by 600. All of the columns that are 600 by 600. So the only thing I'm left is this that is 450 by 450. Then I paste the bars in there. So it will automatically just, whatever parameters I placed there have been adopted on these other columns. It will take a bit of some time because there are a lot of them. Okay, so we're using the same type of reinforcement now in all the columns. Then even the ones that failed should essentially pass. So everything that I've edited where I put that should pass. Let me attempt to wait. So this one, I've done that, but it's still failing. So it's still at 1.0 that. So this column may be receiving a lot more loading compared to the others. So usually it's either you increase the cross section of this one or you do a bit of some steel magic there. If I say, okay, I'm going to use Y32s all through, still nothing is working. This one I suggest we increase the section. So what is this column?
Can you hear me?
Yes, I can hear you.
If this pattern is passing on a neighboring column, usually what you need to do is you try to reset where you were just from, reset and place them back, and then you move away, see if it passes.
Okay, so then I copy. Ah, interesting. I didn't know that. But why? Have you not done that? But have you seen what I've done? I've tested the bars and it's gone back to. And I can't have white walls in this. Look, I can do reset.
Reset bars, and then
giving
you put here on the right here, put the ones that you want, or the ones that are in the neighboring one.
Okay. Here we go. 25. 25. Shear.
This one usually goes with experience. Like if you've seen it work somewhere else, then it can work.
Okay, it has passed, but look at the utilization ratio. The utilization ratio is not making sense. It's 0. Okay, anyway, it has worked. Okay, let's try it on the 450 by 450 column. This is, you guys are hacking the system. These columns are not really passing. They're just, you're forcing them to pass.
Now, if it's worked before, of course,
That
a 600 section is very big. And if you use right tools for 7-story or 25, and it's prone to pass. How about the people that didn't have design software?
no, but then this is a hack. Look, it's not giving me a utilization ratio. The utilization ratio is 0. See? 0. It's supposed to give me a utilization ratio. This is a hack. You are hacking the system. You are hacking the system. Because look, okay, if this is passing, so, okay, look, like for instance, this one. See, if this one is passing, with this reinforcement and with this cross-section, essentially when I copy these bars in here and I place them here, they must pass, but they are not. You see, what I've done here is I've whatever hack I did by resetting. Okay, I think when you reset, you get rid of all, even the parameters. You know how that, like your router, if it has got certain settings, you reset it, it will go back to default setting. So meaning even the load, have you seen these things that are here? These, I think when you reset, I think something gets confused here. That's why it's passing. And it doesn't make sense. You can't have white wolves in a 600 by 600 and they are passing at 0 utilization ratio. You get my point, Ka?
Yeah.
Anyway, so essentially the reset thing works, but it works by hacking. Okay, so how do we make these guys pass now? You've seen the I think the only thing I can reference is we have to change the cross section using the that side where we came from. So if we go step by step with this, we may chew into our time. So what I'll do is I'll go to beam design. Already we know if we're able to change the cross section and some of these passed, then we may need to change the section again. Maybe try just maybe one step up, like 700 by 700 columns, and they would work. And there's a structure where I went. I think they used 800 by 800 columns. Even at 873, remember 873 and suburb? There's some 800 by 800 columns. Another thing that we can do, just for purposes of having this run, is okay. We close that. We can just come. Program will be terminated. Cancel. No. Okay, what we can do is this. We can come to analysis, then just play around with this. Okay, we delete the loading generators and just we generate just normal load cases for dead load and for live load, and maybe just wind as well. Okay, so we have just these load cases.
What else did you put?
I should think unassigned loads will be deleted, yes. So we'll analyze again, but it will take a lot of time. This also sometimes so this is the tricky part about this process of Prota. Why method ya kustariseti ya 19 aisho
mwenso kuvumia po mwe.
Okay, look, what is utilization ratio? It's a ratio of
Isn't it the ratio between profit and skill?
The actual well, here we're looking at maybe area of reinforcement. If we're looking at the area of reinforcement, the required area of reinforcement, okay, divided by the provided area of reinforcement. So when you have required area of reinforcement by area of reinforcement provided, so what you expect there is the figure should be less. Otherwise, if you put provided, if you have where what is required is greater than what is provided, then you have a factor that is more than 1. And in that case, what you mean is that you require more reinforcement, but you provided less. So the reason why it has to be less than 1 is because you need to provide more reinforcement than is required.
Yeah.
So it always has to be less than 1. So if you have like 0.5, 0.6, 0.7, that's around the correct place where we should play around. Otherwise, when it just says 0 and you have white wolves, then what it means is you have provided more reinforcement than is required, and it doesn't make sense that white wolves
No, you're
are more
misunderstanding.
than what is required.
Oh no. You're
I don't know if
misunderstanding. You're misunderstanding. So when you press that command, the reset bar, what it does it takes the minimum reinforcement that minimum bar size that you had selected in the what's that thing? Not in the post analysis, the one that comes before pre-analysis. So for example, if you had decided that some of your columns
Yes.
have y8 and then y16s and y20s, when you reset, it will go to the minimum, and then it allows you to choose the ones that you want according to the, as you explain, the utilization, the steel to concrete.
Okay.
It's not like it's
I haven't just opened the. Wait, still. Utilization ratio applies on the steel part. Like the provided steel in comparison with the required steel. Are we on the same page, or I've gone astray?
No, we're actually. Hold on, let me open some. Here they're talking about its used capacity over total capacity. Another one is saying, I would say it's more specified load over design load.
what is it saying is the utilization ratio?
Okay. So they're saying it represents how much a component of a structure,
Okay, so
either a beam or a column, is utilized compared to its capacity. So if a beam's utilization ratio is 100%, then it is holding all of the load that its capacity allows it to hold. I like to tell people to think of it as percent stress.
we still have that issue. We still have that issue. So look, let's you know, the at the end of the day, let's do this. And then there's something I'm looking. There's something I'm looking for. Children.
Yeah, Ashambo.
Where is that filter? I think it should be on view.
When you want to filter out certain elements. I don't know where 2025 has placed it. Maybe you go to modeling, maybe. Because you usually often use it on modeling.
I've filtered. So I highlighted everything and I filtered. Now it's only clicked columns. So I want to change the cross section. You've seen what I've done, huh? Okay, let me do that again. Okay, so this is the structure. So I highlight everything in 3D. Then I right click. Then I go on just members, not on the axis, not on the stories, just on the axis, on the members, and click the axis and click the shear walls, the beams, and the slabs. And then I say, okay, so now it's only highlighted columns. Then I can right click and change their section. So meaning all the columns now, I'll change them to 700 by 700. So all the columns in this structure have been changed to that. Then so when it's your project and you have all the time, you can be doing trial and error. You try this one, you try this one, you try this one. But in this case, for the sake of time, you can just assume something, regardless of whether it's designed or but designed just for purposes of having progress. So remember that trick that we did where we were changing the section of the column flow to flow. You can actually experiment with that and say, okay, the big columns are in the lower stories compared to the upper stories. Chafriza.
So for this structure, since what foundation do you have in mind?
Piles. Pile foundation. So pile goes with pile caps. So I'm going to have piles and pile caps. They may not be very deep pile caps. May not be very deep piles. Maybe we can take them like to 10, 12 meters. So that means our deepest foundation will go to 14 meters below. Ati?
I'm saying you like to be safe. If for a 7-story building you use piles, how about 24-story?
Piles again. Okay, yeah, we can try. We can do even combined pad footings. That's also workable. So you've seen now what it's doing. Now it's not having a struggle because the columns are passing terribly. Now it able to cap off. Then it was slow because it was trying a member. Yeah, kana try like that. But now it just flows through the columns because
all of them, if not most of them, are good.
all of them are green.
Yeah, increase to 700.
Kuma beam nakwenda kwalawo obwafya nakwenda twalachinja ama dimensions.
So this is a question there. I don't know if you want to take it.
Okay.
Yes. Sorry, I lagged behind slightly. You said change the dimensions of the columns to what by what?
700 by 700.
Okay. What about the reinforcement?
We're coming back to it. So now, I remember I said in a typical design, you first change the section, then you come and add the area of reinforcement. Because the area of reinforcement is usually also a factor of the section size of the member. So after this, now we're going to the reinforcement, then we adjust what reinforcement we want to work in there. So the adjustment of the reinforcement is a factor of the utilization ratio. So based on the size of reinforcement that you, area of reinforcement that you place in, you'll be checking against the utilization ratio. We want the utilization ratio to fall within a ratio of 0.5 to 0.7. So you play with the reinforcement for it to meet that. There's also the other item that you look out for, which is it's called the percentage of steel supplied. So you can check against the codes, like what percentage of steel is required in a column. Usually I think 2.8, something like that. So if you have met that and you have met the utilization ratio, then you are good.
What about if you forgo that utilization ratio and then you just focus on the area of steel required in the section? Will it fail or will it pass?
It will. If the utilization ratio is not satisfied, it will be red, so it will show that the column has not failed. So essentially, for a column to pass, it has to satisfy the utilization ratio having to be less than 1, regardless of whether the percentage of steel is 2.8 or it's 5%. So one of the first things you check out for is that whatever area of reinforcement you've applied, it should meet the required utilization ratio. So the utilization ratio being the area of reinforcement that is required divided by the area reinforcement that you have provided. So so each column, each section, remember I said the steps are that you change the section first. So for that particular section, there's a required area of reinforcement that you're supposed to put. So what you're playing with is the provision. So you're playing with the provided area of reinforcement so that you can meet the ratio. It's like you're looking for x when you're given y, and you're told x plus y is equal to 5. So you'll be adjusting the value of y so that you can meet that 5 that is inside. If you're given that x is maybe -4, you get the sense.
I understand totally now. Thank you.
Yes. So first step is getting the cross section to be satisfiable, and then we go now to applying the steel within that section, because each section requires a certain percentage of reinforcement. So once you have achieved the section and you have agreed to say, okay, me, the section that I want, there are some cases actually where you say, okay, I don't want the column to be more than 600 by 600. Then you have to use alternative means of having that 600 by 600 satisfied. What are the other things you can do? We can go and reduce, we provide some grids in between our grid lines and provide columns in strategic points where we reduce the span of the slab from one column to the other. That way, we are reducing how much axial load is imposed on a column. Increasing the number of columns, reducing the span, thereby reducing the effect of axial load on a particular column. So, in an event that the axial load that is going on the column, that is causing the column to have to be increased to 700 by 700, is maybe 500 kilonewtons. What we'll do is, we just have to, let me just illustrate it here. Oh, where is the eraser?
Start a new one.
Eh.
Start a new
But
one.
in terms of
Start a new
that
one.
cost more.
Huh?
In terms of economy, won't that
Not
cost
quite that
more?
boy. In terms of economy.
Yes. So let's say your structure has got 50 columns, but want to satisfy 600 by 600. So you're saying you have to add more columns to reduce axial loading in certain zone. Won't that increase the cost of construction?
Yes, it will. So for engineers, we are sometimes limited by architects, because the architect will say, no, me, I don't want a column that is larger than 200 in width, because I want the column to be hidden in the blockwork. So then you have to know what you to do as an engineer to make that satisfiable. If you come and give the architect a 400 by 400 column, and he wants the columns to be hidden in the blockwork, you will fight over that. So what do? You just use the same 200 by 400 that he requires, and just reduce your spans. If you have double the number of columns, well and good, but you have satisfied his aesthetical pleasure. You get.
All right. Well,
so in this case, maybe the reason why we don't want to have more than 600 by 600 is because that's the only allowable size that the architect has proposed. So you provide other measures now in trying to reduce loading that is going to your column, essentially reducing the direction of the column. I hope that's clear. So in an event that we have something like this is a grid line, and this is the other grid line. So we have something like this. So we have a column here. Let's use a different color. We have a column here, and the column here. And we have a column here, and another one here. Then the architect says, me, I don't want this width that you are putting here. Me, I want the column here to be like this. Then when you try this in your software, it's refusing, it's not working. So what do? You say, okay, if this is what you say you want, me, what I'll do is I'll come and put an axis here. And then I put another column here. So what I've done is, if this is the slab,
which is about 7.
let me use a visible color. If this is a slab, okay, and it's a what? This is a spanning slab. So we'll cut it in half here like this. So there's this load this side, okay, and there's this other load this side. We'll put it in green, and there's this other load this side. So you have a beam here. Here, remember, you provided another column here, similar type of column. So you have reduced the width of his columns to what architect was. So you have these beams here. You have a beam here, and you have a beam here. I hope my drawings are making sense. Then you have another beam like this, and then you have another beam probably like this. Okay, so you have play when it comes to these beams. You are able to make them wider because you have 400. You see, the column is longer in this direction. So you can do 400 maybe by 500, and this is satisfiable, okay? But in this case, because your column size is, you're only allowed to do 200. That's why you had to cut this in half and put another column here. So what you're going to be doing is whatever load will be coming to this beam, divide by 2, half of it goes on this column, half of it goes on this column. But this column is not only receiving this loading, it's also receiving half of the load from this beam coming here. So if you have 20 kilonewtons imposed from this beam on this column, and even this side, maybe you have 30. So what you have done is, in an event that you only had, let me use red, in an event that you only had this column initially and this column, you are going to have, instead of this 20, because this is 20, there's another 20 here. So the 20 goes here, the other 20 comes here. You are going to have 40 coming on this column, 40 kilonewtons, plus this 30. So this column was going to be receiving 70 kilonewtons. Okay? And that 70 kilonewtons won't work for this size of the column. That's why we say, okay, let's provide another grid, provide another column, and hide it in the same wall that the architect is saying has to be 200 here. So what we have done here is that we have satisfied the requirements of the architect, but provided extra support for our structure. It comes at a cost, quite all right, but it satisfies the primary conditions of the architect. So that's another way of resolving that issue. In this case, we went with just changing the size of the column, increasing and increasing and decreasing, but there are times when increasing is not required. So you have to do other measures. For instance, if we look at this, we say our spans are 5 meters. So you may have to reduce maybe to 2.5, so that you essentially reduce this to a 400 by 400 column, and it may work because then the load has been reduced. Yeah, so all the columns are abstract. So we come to, I hope I've answered your question now.
Yes, you have.
Great. So we come to design columns. So all the columns now have passed just from the section whatever. But they've passed with what? With some have got white cove reinforcement. Or did I not see correctly? Actually, they've passed the same steel settings that I had put. But let's go back to that. So we're going to provide we said we'll put what, 32 in the corners and maybe use Y20 in the mid. So let's see, what is this saying? Saying the utilization ratio is 0.29. So with this utilization ratio, if we distribute this column, okay, over everything, what is the maximum utilization ratio that we will have? We use the same settings on all the other columns. Here, then paste. Then we'll find that the maximum utilization ratio now looks like it's a 0.36. Okay, done. So we are checking on utilization ratio now. You've seen our utilization ratios have reduced so much. So we may actually even have to change some. Okay, you see, some like this one is 0.76. So now what we can be doing now, provided still 1.17. If we check code, I don't know where I've put my phone. But Shujin, are you able to check just
which one? The BS81?
required percentage? Yes. Required percentage of reinforcement in a column. Or even though I'm using Eurocode, these things are similar. You can just check.
Okay, no problem.
Yeah, it's something between 1% and 8%. But just check the specific. According to BS. Yeah, so looks like we have, you see, so the percentage of reinforcement is around the same because we are using the same steel key. So the applied steel in percentage is 1.17. But how does that affect the utilization ratio? It affects it differently. Some you find this, it's because of difference of loads. Okay, so for some like this one, 4C124, 4C125, it's because of the type of load probably acting on that beam, on that column, sorry, it's less compared to the load that the other one is carrying. So you find that the effect of the reinforcement or the utilization ratio on that column, sometimes the ratio may be lower, meaning that the column is more over-designed. If the utilization ratio is higher towards 1, then the column is more reasonably designed. Yeah. So what you can do is you can just have a factor that you want. You say, okay, I want my utilization ratio to always be 0.64. So for instance, this one, this column, column 9 can 9. So it require in Y25, Y25, that's when you do accept. So for this particular one, there's so much load that we have to increase the percentage of reinforcement a bit. You see. So we have used 1.46 percentage of reinforcement to be able to achieve a reasonable utilization ratio. So why did we have to increase reinforcement? It's obviously because of the load that is active on this particular column. Same cross section, but more load, thereby requiring more percentage of reinforcement for it to have a reasonable utilization ratio. So that's the mathematics that's happening there. So the ideal way of designing is you have to apply reinforcement in a way that is personalized to the actual member or actual column. But in our case, we just used one, copied, and pasted everywhere else. That's why we're having different utilization ratios, even over the same steel of reinforcement applied. So when we go to beams, it's around the same. Okay, even here, these ones have practically refused to pass. Why? Because the steel may be provided does not give the satisfiable utilization ratio. So we may actually have to change steel, but of course it's not the best way, again, to just change and put, you see, the utilization ratio is at the bridge now, it's at 1, so it won't pass. So this type of columns, we may have to go back, either edit the cross section of the column or play around with the layout in such a way that we reduce loading coming to this column. That's how we sort it out. So in summary, what I mean is that you spend a bit more time here trying to have things work because of how the loads are. Okay, so maybe what we can also do, okay, I can go to display, visual interrogation, then I say on column display, I want to show the axial load as a dead load and as a live load. Then I say okay. So
What is a mechanical calculator?
then when I come here, sure,
Yeah, I remember both.
I tell you, Monica.
Oh. Achamuna mu kitabo.
Column display. Display column section. Okay.
Segment is good.
It's supposed to show.
Oh,
It's
you can go
supposed
to
to show.
Have you tried the steel section diagram here? Number 3, but button number 3.
Which one? Huh?
Have you
Still section.
steel section or the column?
I don't get what you mean. Like a column like this, then the still section.
The steel standard. What is it? Oh yeah, it's still standardization on the design tab there.
Like for to show the still in here. You mean like display?
Yeah. What is it?
I go to display and then I click on views. I Cosmate.
Mm.
I want to see this.
What is it you want to achieve?
No, what I'm trying to see is I'm trying to display the loadings, the loads of each column, so that we can see the difference. It's supposed to show
Oh,
on visual interrogation. You
some
get, huh?
some.
Like
How
when
about
you're
on the report here? Go
when,
on the report here on design. How about if I don't know if I'm behind. Oh yeah, my video is behind. How
wait
about
first
if you go
for
on the
it to
report?
finish too. Hmm?
You go to any column, you hover over it, right click, and then you go to the
Okay, wait, let me just finish what this is. I hope this thing that I've tried to do doesn't crash the software.
Let's make sure you save.
Hmm? Because I'm trying to show reinforcement for the all the columns should show in 3D. I must see the bars.
Oh, that's what you mean.
That's what I thought you meant. So
No.
that's the process that I've started. Ribbon model, it has created now. Let's see now. So when I click, eh, mm, wala crash the software first.
Just created and configuration.
So this won't work.
Yeah, no. That one I wanted you to do it in 2D as a matter of fact.
Ah, you're referring to communications.
Referring to what?
Column applications, the 2D one is called column applications. Yeah, what does it? I've seen you sent
Zero code. But none can BS code but checking here. BS code is part 1 code of practice for design and construction. It says minimum reinforcement ratio for slabs. The minimum percentage of reinforcement is typically 0.13 or 13% to 15. Actually, 0.13% to 0.15 of the cross sectional area. For beams, the minimum tensile reinforcement is 0.2.
0.
Then for columns, it ranges from 0.8
So
to
it's
6%. So columns have a relatively high
0.8 to 6%. So when we put the way we put 1.17%, it's okay. It's within that range.
But also here something
No.
talked about something that I also wanted to mention when you are doing. It says to ensure proper concrete compaction and avoid congestion, maximum reinforcement percentage is usually 4 to 6% of the cross sectional area. Because you remember if we're using
That's
40,
a
if we're using 40 millimeter, if you're using C40, if you need C40 grade C40 MPa, it implies that your minimum or your maximum aggregate size should be about 20 millimeters. So if you're placing them like that, you need stone in between, not just have that mortar.
It's best.
So if you
okay, yeah, right. I think my internet may just be issue.
Oh, if that's the case, then where do you suggest you end the video so that we do not extend it? 2 hours of reviewing. Can sleep, can?
Okay, I'll stop recording just now.
You know you can pause.
Then once this is done, but you edit the. Okay, are you? What did you say is the app I need for?
For now, you can pause. If you do not want to record this, just go on OBS where there is that pause button. Just pause and the light changes to, I don't know if it's yellow or orange.
And I've actually, I didn't know it could pause, so I had to stop.
Oh.
So what is the app for recording for? What is the app for
editing?
The app that you said editing is.
It's called Clipchamp. Just go to your Microsoft, press the Windows button and press Clipchamp. You'll see it.
Clipchamp.
Yeah, so when I press my Windows button, I just type Clipchamp. So Microsoft Clipchamp. You open it. If you're using Windows, I think 10 or 11 or above, you'll find it.
Oh, it's actually embedded in the.
Yeah.
It's actually in my.
It's a Microsoft product, so they attach it. Especially for you, our friends who pay for Microsoft products.
Oh yeah. Yes. So for me, I should have it free.
Even Let me have it.
Okay, great. Okay, okay, I have it. I'll edit and then upload. I'll edit and then upload. So we can continue tomorrow.
Yeah.
I think you are seeing my screen. Aren't you?
For me, it had your screen. It had paused on the column reinforcement design. The table. Because I'm like a bit.
Okay, so we I think it's my internet that has. So we can continue tomorrow, I think.
Okay, no problem.
For these ones, I'll fix the columns. Then tomorrow we can do the beams.
Okay,
I'll record I'll see if I can the session where I'm fixing the columns. I did a different recording. Yeah. Okay. This is the end of class. Good night, and see you tomorrow.
Okay, cheers. Thank you so much. It was a nice session.
Thank you. Thank you so much.